thanks for being here. I am Wayne Dennison. I'm a board member on the Wabash Valley Riverscape. And I think for those of you that were here last night, you heard Kent say he's been on the board 12 years. Well, I'm a new member to the board. I just started this year, but picked a very good year, I think, to get started because we've had a lot of exciting things happen this year. One we're excited about now is the Smithsonian exhibit, the Smithsonian Waterways exhibit, and we have a companion local exhibit called the Pearls of the Wabash. They're both on display at the Vigo County School Corp Administrative Office here in West Terre Haute. It's on Olive Street. We're also sponsoring the speaker series. Tonight I have the pleasure to introduce our speaker and a colleague of mine, Dr. Marincel Payne. She's an associate professor of environmental and civil engineering at Rose-Hulman. She has a PhD in environmental engineering from the University of Illinois at Urbana-Champaign, a master's degree in environmental engineering from Missouri University Science and Technology, a bachelor's degree in nuclear engineering from the University of Missouri-Rolla, and she co-leads an undergrad research community to support learning through research and leads undergrad research on engineering treatment wetlands. So please join me in welcoming Dr. Marincel Payne.
Thank you so much, Wayne. It's a pleasure to be here. And I had a hard time finding a parking spot, so I'm just so tickled that you all are here to listen to my presentation tonight. I'm really excited to talk about wetlands. It was getting dark as I was coming over, but I always enjoy looking at the Wabashiki area whenever I venture over to West Terre Haute, and I have not been on the boardwalk yet, but I am going to make a point to do that before Christmas. I'm so excited that that is part of our community now. So I wanted to set the stage with some definitions of just what wetlands are and the benefits that they provide us. This is a natural wetland, and natural wetlands, before we talk about the constructed ones, natural wetlands perform important ecosystem functions. They provide flood storage, it rains, it provides storage for that water to slow the peak flow of that rain runoff from that rain event to surrounding downstream areas. It also cycles nutrients, cycles carbon, and also provides critical habitat for animals, provides critical habitat for plants that really benefit us collectively, economically, environmentally, and socially as well. They also are able to actually do some more detailed cleaning of our water. They can actually even remove some harmful pathogens from our water. And natural wetlands can be defined as ecosystems that are seasonally or permanently saturated with water. Now, I'm going to talk at the end of this talk about some of the changes that have recently happened with respect to the Indiana Isolated Wetlands Wall, just to kind of provide some information that I've learned this year that I thought was really interesting. I am by no means an attorney. I am just a professor at Rose-Hulman that really is excited about wetlands, and I've had some students build some constructed treatment wetlands. So that's my perspective. I just wanted to share it with you. So we'll talk about some of those changes to the Indiana wetland situation a little bit later. But according to the Corps of Engineers, both federally and at the state level, this is the definition from their manual. So wetlands are areas inundated or saturated by water at a frequency and duration sufficient to support, under normal circumstances, vegetation that lead to saturated soil conditions. So there are three things that have to exist for something to be considered a wetland. You have to have the vegetation present, wetland vegetation present, plants that can survive in saturated or partially saturated land. You have to have the soils, hydric soils, that means soils that have a large water component to them. And then you have to have surface water present at some point in time. Now that can be fed by groundwater, which we're going to talk about when we talk about the isolated wetland situation. But you have to have water or saturation of that soil. Now, I obtained this slide from some colleagues at IDEM just to kind of show some of the different and complex aspects of wetland regulation. And I'm not going to go too deep into this, but I just thought it kind of gives a sense of how complicated and complex this is. Wetland regulation is all out of the Clean Water Act. That's the genesis for any type of water regulation, whether it's wetlands or just surface water. So public fresh water is regulated by 3 agencies. I'm going to define the terms here. IDNR is Indiana Department of Natural Resources. USACE is the U.S. Army Corps of Engineers. And IDEM is Indiana Department of Environmental Management. So then if you go upstream, navigable waters have traditionally been defined as those waters that allow for interstate foreign commerce, that allow for, and it doesn't even have to be current, so it can be historical. So the Wabash is a navigable waterway. I think the St. Joe River is. The Great Lakes, definitely the Ohio River, and there are probably others in Indiana. I just haven't been here too long to know all of them yet. Tributaries to those navigable water bodies are also regulated. And then you have the contributing land area to those tributaries to the navigable water bodies. And so those are regulated by Army Corps and IDEM. We have floodways of the tributaries and of those navigable water bodies. We have non-wetland floodways, so areas that really do dry out and really are only inundated during those larger storm events. And then we have different types of wetlands that there are a lot of different definitions, and even if you start to break them down, there's categories within those different categories. So you can have adjacent wetlands. The new term, I think, is that a wetland abuts, so that's kind of the new terminology. It's been changing a lot in the past year and a half. And then we can have isolated wetlands. And you'll see this is the one with only one little agency listed there, and that's where IDEM was regulating these isolated wetlands. And they can be connected by groundwater during some parts of the year or more parts of the year, so more or less parts of the year, to these tributaries or to the navigable waterway, but they're not connected necessarily by surface water. And so there's some gray area there that allows for interpretation differently by different administrations. So just to kind of give you a sense, at the federal level on the left and at the state level on the right, depending on where you are, you're in different districts, they break that up, just to kind of give you a sense of how they're operating. But I want to take a step back. Now that we have some context for how wetlands and water bodies kind of are divvied up and the different agencies that all have to work together, a watershed, as defined by John Wesley Powell, who was an explorer and geographer, said a watershed is a bounded hydrologic system within which all living things are inextricably linked by their common water course. So I think it's just worth remembering as we kind of think about what these mean to us from a sustainable perspective. And Dr. Padgett yesterday talked about the economics, the environment, and the social aspects of the benefits of these wetlands. Kind of what that means. We'll circle back to that. Okay, so Indiana has lost a lot of wetlands. A lot of the states around Indiana, Illinois has lost a lot of wetlands. When European settlers came in, they noticed the nice fertile land that was swampy, maybe not all times, but different times of the year, started putting tile drains in, and we drained a lot of our wetlands to build farmland, or to use our farmland. So now we have 3.5%, and of the remaining of those 3.5%, the 10 to 20% are federally regulated. So the state regulating that additional piece was providing a critical buffer to what might happen or might not happen federally. So I wanted to kind of give us some sense of what those different types of wetlands are. We only have 3.5% left, but there's still a large variety and diversity in types of wetlands. So we can have forested wetlands. The wetland can be in the forest or by the forest, adjacent to the forest. So having more wooded type plants. You can have shallow marsh or open pond that's either not connected to a stream or connected to a stream. In many cases, these are connected by groundwater. Sometimes they're not. So this is where the different designations of wetlands come in. Sometimes they're just precipitation based. More carbon storage has been found in these shallow depressional type wetlands that are not necessarily connected. So in a changing climate, these are really hard workers in capturing carbon. You need the slow moving water to allow for that accumulation of carbon. And so there's even some intuitive sense that, okay, that makes sense. We're not just washing things out as readily. You need a low dissolved oxygen content. So in water, as the aerobic or microorganisms that consume oxygen are eating up some of the carbon that's in the water, the dissolved oxygen in the water will decrease. It's not instantaneous to transfer oxygen from our air into the water. And so there's usually higher oxygen content at the top of the water and lower at the bottom. And so these slow moving water bodies aren't mixing, and they also allow for that low oxygen content situation to occur. Does anyone know what an ephemeral stream or ditch or flooded or water body area? So an ephemeral, in this case it's a stream, the picture I have here, means that water flows or pools only in response to precipitation. So it's a little bit different than intermittent. Intermittent means that there is some groundwater connection at some times of the year as well, so it's more than just precipitation. These also were, depending on the types of regulations, they have gone back and forth on whether they're regulated. There's clearly a drainage there, but it's not in use all the time because we have different weather patterns throughout the year. So I just kind of wanted to define that for you because you might hear that term. Sometimes we have trash, tires, but luckily we also have lots of turtles. And there's lots of nice wildlife right over there. So the functions of wetlands include the storage, the wildlife, their breeding grounds, they improve water quality, they prevent flooding, and they allow for recreation. Sometimes we forget the fun factor when we're talking about these kinds of things. I do want to note that while researchers have found that the depressional type wetlands can store carbon more effectively, all types of wetlands have value. And so there is good reason to be able to provide environments for all of them to exist. So my interest in wetlands, this is not anything I did during my schooling, during my PhD. It's very different. I got interested because students were interested in constructed wetlands, and they wanted the opportunity to try to kind of see what that looks like. So I got involved in a project where we built some constructed treatment wetlands. I'm going to talk about how that differs from a natural wetland. In that, because these natural wetlands are so beneficial, we can try to emulate some of those same processes to treat some of our waste streams. So stormwater and other wastewaters can be treated to some degree in wetlands. What's the problem with using wetlands to treat water? What do you all think? Maybe based on some of the pictures I've shown, or just
the trashing.
Okay, maybe it is a problem for dumping grounds for some people.
Smell.
Okay, there could be an odor. Okay.
It could be poisonous to wildlife.
Oh, maybe some of the waste that yeah, absolutely, sure. There's a big one, just logistically, that makes it really hard. Time, it takes longer, and so that translates to a larger area. That Wabashiki wetland takes up a lot of space, right? From a development point of view, that kind of is inefficient, right? From that perspective. So In communities that have some land, we can start to think about putting in wetlands if we aren't constrained by that. Now, usually when we're treating waste streams, we're not taking raw sewage and dumping it into a wetland. Usually it's a tertiary, a final polishing type step from the wastewater treatment plant. And I'm going to show you an example of that. Okay, so an engineered wetland, can I turn this a little bit? Okay. An engineered wetland is saying we have some water body, we have some land, and we have some organic content. That's the waste coming in. Those are the components that are interacting with each other. And we can remove our pollutants by the natural filtration of the wetland, the microbial activity. We kind of talked about some different amounts of dissolved oxygen in the water, so different amounts of activity, and plant uptake. So the plants need nutrients that might exist in the wastes. And so the idea is, can we utilize the natural benefits of the wetlands to improve our water quality in an engineered way? Okay, there we go. Combined sewer overflows. Does anyone know what that means? Yeah? Does anyone want to explain it? It's okay if not.
Water comes off of roofs, driveways, and eventually ends up in the river.
Okay, so it definitely is water that is a waste stream that's not treated to the extent that we typically like. Go ahead.
Towns tend to dump their storm sewers into their regular sewers in what do you want to say, like really wet periods, and it just all goes out.
That's right. Okay, perfect. So we're putting both of you are saying this. So we're putting the stormwater in with the wastewater, and we have that in most of Terre Haute. Most older cities have that. In fact, parts of Europe have a newer system just because the US, even though we're younger as a country, we haven't had to rebuild our sewer system in ways that parts of Europe have. So what happens is, during dry weather, this POTW stands for publicly operated treatment work, so a wastewater treatment plant. It's fine. We have waste coming from all of us use water, and we have wastewater, and it goes to the wastewater treatment plant. The problem is, during wet weather, if we have the stormwater also going to that same pipe system, we're going to have to, like our friend here was saying, we're going to have to put some out into the river that's not treated. And so, yes, is it diluted? Yeah. But it's still putting untreated sewage into the waterway. So the EPA has said you can't do that anymore. They started with Chicago and New York City and big cities, and now they're down. The Terre Haute is under consent decree to reduce that, and that's why we've expanded the wastewater treatment plant. There are different ways that different communities have looked to manage that. In Indianapolis, they're putting in underground holding tanks, same in Chicago, tunnel systems that essentially take this water that they would have put out to the river and letting it go down into a big pipe storage system. After the rain event and after the wastewater treatment plant is kind of back to its normal, then they start pumping that water through the wastewater treatment plant and then release it during non-storm event situations. Another alternative that I'm going to show you is maybe we could use a wetland to treat this type of situation. I kind of added this slide, so I feel a little awkward now. I think I should have left my initial order. So I'll show you that in a second. What I want to mention is, aside from the pathogens that are being released, the other problem is the release of nutrients. So eutrophication, how many of you are familiar with eutrophication? Okay, we'll go ahead and describe it. I'll go ahead and describe it in the full process. This actually is it's kind of a confusing concept. So when there is nitrogen and phosphorus in our water, that's fertilizer. And so the algae love it. They can grow, they can go crazy. You've probably seen that in some of the lakes and stuff around. The problem is that algae will eventually die and sink to the bottom. Now, bacteria exist because nature is good about recycling. Bacteria exist that can consume that. They also consume oxygen in that process. So we breathe oxygen and we you know, I don't, whatever you had for dinner, right? Something good, I hope. So in terms of your body breaking down that dinner, you're consuming oxygen to be able to get energy out of that process. Same thing with the aerobic bacteria that are using oxygen to break down the algae. They use that oxygen, and then all of a sudden there isn't any more oxygen. And so it creates this dead zone down and downstream. In the Gulf of Mexico in 2017, it was the size of the state of New Jersey, which is a smaller state, but it's still kind of crazy to think about. It's called the hypoxic zone. There's no oxygen, or the dead zone. And it's the biggest that it was, in 2017, it was the biggest it had ever been. So it's been getting, the problem has been getting worse. Unfortunately, Indiana is one of the largest contributors. Illinois, Iowa, Missouri, we all contribute because we have a lot of agricultural practices that go on in our states. So nitrogen and phosphorus are what we're talking about here. So in one of my environmental engineering lab, I had students kind of think about this problem, and even from an economic perspective, because there are economic consequences. There are economic consequences to maybe changing farming practices, but there are also economic consequences to the water quality that affect all of us. So they kind of looked at in locally, and then in Indiana, and then regionally, what are the economic impacts of that as water moves from the Wabash to the Ohio down to the Gulf of Mexico. So I promised I would show you an example. Here's a constructed treatment wetland in Washington, Indiana. I went and visited. It was really cool. So just over here, you can't see, there's like a settling basin. Now this is after the wastewater treatment plant. During wet weather events, this is for treating of their combined sewer overflow that they would have just dumped into the creek. You can see the creek is back here where the tree line is. And I don't remember the name of that creek. So instead, there's a little settling basin to kind of get any leftover gunk out. And then it goes, or any gunk that is in the combined sewer, because it hasn't been treated yet. It's very dilute, but it hasn't been treated. And then it can go through this wetland process, and there's a flow control structure to control how quickly it moves through that wetland and it goes out. And I think they also disinfect using UV. They also are monitoring it. I mean, they have parameters they have to meet because they're permitted for this process.
Is that part of their wastewater treatment plant?
It is. Well, it's for only during wet weather events when they exceed the capacity of their wastewater treatment plant. And
is it on municipally owned land?
I believe so.
And did the municipality pay for it?
I think so. Just like we are paying for our expanded treatment plant, just like Indianapolis is paying for the tunnel system. And that's actually one of the benefits. If you have the land, and if you can maintain this, it's actually a low-cost solution. Not many moving parts. There's some control structures at the end. They have monitoring equipment. They have to do disinfection just because there could be pathogens, especially in the summer months. Here at Terre Haute Wastewater Treatment Plant, they only disinfect in the summer months also. But otherwise, they have to keep invasive species out of there. That's one of their stipulations. But otherwise, it's kind of self-operating, which is
not in the floodway.
I haven't looked at a flood map for that specific wetland, but I imagine that when it was designed to not be flooded because it's meant to operate during wet weather events. And this was put in by Lockmuller Group, so they're a civil environmental engineering firm. If you're interested, the person that took me on the tour, I can see if I can get you any more information. And if you do go to Lockmuller, Lochmueller, this was, they have a little blurb about it. One of our alumni from my department that I knew had gone to work with them, and he kind of finished up the tail end of the project. He's no longer with Lockmuller, but at the time he was, and I got a tour of it. It was really interesting to get to see it. It's only a few hours from here, so kind of a nice example. I wanted to just show you, I just have two slides that are from a recent webinar. The Purdue Center for the Environment has put on different webinars, and I'm not involved in it in any way. They've just done a great job. I've had my students watch them, and for a variety of topics. And I just wanted to, talking about constructed treatment wetlands, I just thought they demonstrated this well. Wetlands can remove 5 times more nitrogen than simply taking farmland out of production. So it's really an important, wetlands can serve a really important purpose in terms of reducing that nitrogen. And then in terms of the ephemeral wetlands impact, so remember that wetland that is only existing from precipitation events, they can become connected because of flooding and other situations. Maybe they're not groundwater connected all the time, but when it rains, the groundwater level rises and they become connected, surface water and or groundwater connections. And so during the highest flow, they found that nitrogen removal was greatest, most greatly removed by those wetlands. So they really serve an important purpose. So back to kind of my involvement. We, in the greenhouse at Rose-Hulman, my students built some wetlands. So we have 2 kind of wetland systems. They have 3 compartments each. So this is a picture of, you can't see it too well. We had leaking issues, and so we had to line them. The idea was originally that you could see in some plexiglass and see them. The difference between the 2 systems that we have is that one has a free water surface, has open water, and the other one is subsurface flow. So I think you mentioned there could be an odor with some wetlands. So the literature says there's a potential slight performance increase from the free water, but there can be an odor, and also it can be a vector for diseases like mosquito-borne diseases. So subsurface flow is maybe more desirable. There's potentially maybe a little bit less effectiveness of that system. You don't have the settling as much as you do in the water column as with free water surface. And I wanted to mention, the subsurface flows have been more popular in Europe, which has more early way adopted constructed treatment wetlands. So just to kind of show you where we started with this project, you can see I wanted to show you these pictures just because you can see in there a little better. So we have 3 different basins. The first basin was designed to remove turbidity, or the cloudiness, the particles in the water that won't really settle out unless you let it sit for a really long time. The second one was designed for BOD removal, which is biochemical oxygen demand, but really it's carbon, organic carbon in the water. We just measure it by measuring the oxygen content. And then the final one originally was designed to remove, and the second one was designed to remove nitrogen because of the bacteria that grow on the roots of the plants. And then the third basin was for phosphorus removal. So I'll talk about kind of how that went. But the middle basin is what's different between the 2. So this is now the free water surface. In this picture, the water lilies weren't as developed there. But the 3 basins were the same. And one idea was, can we compare? There's not a lot of data to compare side by side a subsurface and a free water surface. So we kind of wanted to see, was there a big difference there? So in the work that I'm going to show you today, the goals were, we wanted to reduce phosphate, and had found some literature saying we could reduce it by adding essentially limestone to the wetland. And we wanted to see if we pump the water through multiple times, does it get cleaner each time? And so just to kind of give you an idea of, what we're talking about, how we're setting this up, we had started out, students are amazing. I love working with undergraduate students. You all are so enthusiastic. And students were going out and collecting stormwater. When it was lightning, I didn't let them do that because it's kind of dangerous. I mean, even if it's not lightning, we don't want students slipping or anything like that. So the first time we were collecting stormwater, and we said, we're not doing that. So we make artificial stormwater. The retention time, we wanted to see if we pump multiple times, does that improve? And so we have about, in this data, it was 3 hours. We've now increased it to about 6. I'll tell you why. And then we have a sampling location at the outlet of each basin, so we can kind of see the performance after each basin. So this was looking at nitrate reduction. So we want to eventually get to nitrogen gas, which makes up most of the air that we breathe. Nitrate is, we weren't measuring ammonia in this study, but ammonia is usually what is applied, and then that's oxidized to nitrate, and we want to reduce it down to just the nitrogen gas. So what we found is, now the circles are the subsurface flow, the one with not the open water, and then the squares are the open water. And so 0 is the reservoir that the water is starting out. That's the artificial stormwater. Basin 1 is after that top basin, 2 is after the second basin, that long middle one, and then the third is the last basin. So we saw good removal through one cycle. Then we pumped it back through, and we saw it increase again, at least for the subsurface flow. And so what we think was going on is that we put it through once, this high nitrate concentration water, and then we started putting it back through, but it hadn't been flushed out. And so that's what we think was going on. But really, we were doing a great job here. We didn't need to go through again. So that was kind of cool to find out. In terms of phosphorus, we tested some different sizes of the limestone that we added. So first we added some pebbles, and it didn't do anything. So then we said, well, let's go to a smaller size. The fines, like we were screening them. Like if you've ever worked with soil, you can have these like essentially different screens, and they all stack, and you shake it, and then you see the different gradation of the rock. So the fines, the powder at the bottom, is what we ended up adding, and it did a pretty good job in Basin 3 where we added it. Now we saw the phosphate concentration increase again, like we did with the nitrate, but interestingly, it was removed again. So that was kind of cool, telling us that this was doing its job. So that's pretty exciting. We're going to investigate that further. So we found that the fines were effective. The recycle line wasn't necessary. And both of the wetlands performed similarly. Like the lines were pretty close together, which was also an interesting finding. So in the future, we want to look at optimal concentration of the amount of limestone fines to remove the phosphate. And there's other things that we can think about. How am I doing on time? Okay. So that's how I've been involved with constructed wetlands. I wanted to now share that, we hope our students will graduate with the idea that engineers have a responsibility to wear some different hats and a responsibility to be aware of some different regulations that might impact civil and environmental engineering, and also have a responsibility to work with their communities to understand the importance and share the benefits from their perspective of some of the things that they're learning about, like wetlands in this case, or whatever it is that students are learning. And so I wanted to share with you some of what I've learned in preparing in this past year, really, with the changes. And one thing that really stood out to me was that Indiana wetland regulations, the state regulations, really are a buffer to the way that the federal regulations are interpreted under the Clean Water Act. So I wanted to share with you, like I had promised earlier, some of those summary items that I've taken away. Under the Obama administration, there was a lot more coverage of about 80% of the Indiana wetlands were covered. Now, it's changed just even the past few months. Under the National Navigable Water Protection Rule, under the Trump administration, that was reduced to 20. Now the difference is, how do you decide if a wetland is connected to a tributary or not? Does it have to be connected 3 months out of the year? Does it have to be connected 365 days of the year? That's the gray area. And so that's the difference. And so the benefit of Indiana, which was one of 23 states that had some sort of wetland regulation in place, was that it serves as a buffer between the different pendulum swings for different federal interpretations of how they were regulating wetlands. So this just kind of shows the isolated wetlands were primarily regulated by the state. So what I'm going to share now, hold on, one more point before I go into that. Indiana does have a process for impacting wetlands. So just because we protect them doesn't mean that you can't impact them. So if you are wanting to impact more than 0.1 acre of wetland, you have to go through the regulating bodies. And if it's in the state, it would be through IDEM and DNR. And you can, let's see, I have it listed out here. You can buy from a mitigation bank, you can use an in lieu fee program, or you can mitigate it yourself. And so from what I understand, the differences are you're either paying DNR or some other party to put in the new wetland, so to mitigate it in some way. If you're gonna fill it here, you gotta put one in, preferably within the same watershed. Sometimes they group the different ones together. So what I understand, the benefit of the bank or the in lieu fee program is that if the state gets, one here in West Terre Haute and one in, maybe just upstream a little bit, then they can say, well, let's put in one bigger wetland and we'll combine those two, and maybe it's easier to maintain and hopefully be beneficial. And then if you mitigate it yourself, the issue is that you're potentially liable. You have to maintain it. So more and more people, from what I understand, are going towards one of those earlier options. And that's been some changes. They've been changing how they've been doing that over the years. So there was a bill that went through Congress. It's now an Act 389. It was Senate Bill 389 when there was a lot of discussion about it, but it's now an Act. And that regulated a lot less. It currently regulates a lot less than before. So at the same time, this is why it's been confusing. In August, so in Arizona, almost all the wetlands are ephemeral or isolated. They just don't have the precipitation to support continuous type of wetlands. So with the new regulations under the Navigable Protection Water Rule, they weren't needing to regulate hardly any. And so there was a court decision, the tribal peoples sued the EPA, and there's actually been a change. And so now they're going back to the 1986 at the federal level, which does provide those protections. And so there's like a 5-year period where you can do what the Navigable Waters Protection Rule said you could do currently, but through the judicial, it's being regulated essentially through the judicial system. So I have no idea what's going to happen, but we'll see what happens. So the federal is changing and the state is changing all in this last year and a half. So it's been kind of interesting. So what I wanted to share with you is just some information that was from one of the recent Purdue Center for the Environment webinars about this change. And there was a few like myths and I don't know, the truth, however that phrase that goes, I'm blanking on what that actually is. So this is from the Hoosier Environmental Council, and they have a lot of resources. I'm going to show you a resource slide at the end. They're like reasons people might, or not people, but reasons that lawmakers were saying we should repeal this, and then kind of a counterpoint, just to kind of give you a sense. So Indiana shouldn't be more stringent than the federal. I guess if you look back at the regulation, the idea was that there was the pathway for states to regulate some of that. Important wetlands are the federal ones. Well, we know that all wetlands have value. Whoops, did it not go forward? Okay. We obviously get a lot of economic benefit from our farmers, and we want to make sure that we're allowing for economic growth. However, there's a specific exemption for farming practices in the previous bill before it was, or the previous law before it was repealed. And then wetland regulation increases costs of housing. So we all know costs have been increasing. So this is what they, the information they provided. In the last 4 years, 7 housing development projects per year did mitigate for state wetlands, 6 for federal. So the point they were making is that that can't, over the whole state, have had too much of an impact. And then I personally think this is really the crux of the problem, is that, you know, if I own property with a wetland on it, I want to be able to do whatever I want on my property. And I think it comes back to reminding ourselves that air and water are shared resources. And so, you know, I'm teaching water resources right now. I have a few of my students that are here. And we talk about how do we convert precipitation to runoff, to looking at putting in civil infrastructure at different points to either manage that stormwater or safely cross that stormwater. And when we do that, we define watershed boundaries. We just went through, we took a topo map and we defined watersheds. Those watersheds are not the same boundaries as county lines or state lines. I mean, it's just not reality. Unfortunately, if it were easier, that would be great. But you know, if we take some wetlands and we fill them in, we might be flooding our neighbor or whoever is downstream. And so I think that's kind of what I wanted to end with here, is that it's great in Indiana when we can mitigate our wetlands in a way that makes sense, that's economically sustainable. I mean, we have to allow for development. It's what we do. You know, as humans, we have to live and we have to be able to have economic opportunities, but we also have to be able to have those economic opportunities because we're protecting our water. Oh, I just have a note here I wanted to mention. According to the EPA, on average, 1 acre wetland can hold 1 to 1.5 million gallons of water. So if you think about filling, if this was an acre and that was half an acre and that was half an acre, and you fill that in, then you're sending 2 to 3 million gallons of water downstream at the next storm event. And that does have real consequences, even just economically as well. Yeah.
How has the bill that was passed in the state legislature recently to like deregulate wetlands, has that impacted any of this so far? I hadn't.
Yeah, so it's focused on the isolated wetlands. If I can, I'm sorry, I don't know the number, I would just hit the number. The isolated wetlands were the ones that, so the waters of the US, from what I understand, isolated wetlands were attempted to be part of, so we have, you know, POTUS and SCOTUS and FLOTUS, we have WOTUS too, so waters of the US, based on migratory birds, but the Supreme Court had a split decision on that, and so there's now this, it's not regulated directly at the federal level. And so Indiana had this isolated wetland rule, which was, you know, taking care of our isolated wetlands. And so that isn't there anymore, so, you know, presumably that's not protected. Now, in the meantime, in August, that's where the federal interpretation swung back towards being more conservative of our water resources. And so some of the, depending on how connected those isolated wetlands are, whether they're connected 5 days out of the year versus 3 months out of the year, they might fall into that federal bucket now. So it's been kind of a moving target, and I mean, we'll just have to see what happens. I don't know. Let's see. If I go to, okay. So just some resources. The Climate Technology Center and Network just has a ton of information if you're interested in learning more. I mentioned the Purdue Center for the Environment. They've hosted lots of different webinars. I could talk about PFAS all day too. It's a huge issue in our waterways that in Indiana, we don't even know. IDEM is starting to take stock, like actually measure PFAS in our drinking water and in our wastewater. Michigan is, if you look at a map, Michigan and Illinois have PFAS contamination documented. Indiana, it looks like there's nothing there, but that's because we haven't tested. IDEM is starting to test, so that's a wonderful step forward. They've been hosting just informational webinars. I encourage you to check it out if you're interested. They make it very accessible to all different kinds of people. And Hoosier Environmental Council, they provide information on environmentally related laws that may or may not be coming up in Congress, Indiana Congress. And then the Hoosier River Watch, I wanted to mention this because, I'm an educator. I love learning and sharing what I learn. And I think it's wonderful to get involved as citizen scientists. So this is a way, it's not necessarily just for wetlands, but it's a program where you can become, I don't know if certified is the right word, but trained, I guess is the right word, to be able to take water quality measurements and then submit it as part of the Hoosier River Watch. It actually then goes to IDEM, and you can actually contribute to monitoring of the water quality of streams and rivers here in Indiana. And so, there's just not enough employees to take care of all of the creeks and streams and understand all of them. And some of them, like we know, are intermittent or ephemeral. And so, it's nice if you have a stream on your property or next to you, you might consider getting trained. It's a lot of fun too. You can get kids involved. And so anyway, this is just a snip from their website. And if you want to see, this is in Indiana, all the different locations. So I recently became trained, and I'd like to get one started, a site started at the Lost Creek on Rose-Hulman's campus. I just need to do it. So I will. And just want to leave you with, this is in February, there's February 2nd, World Wetlands Day. So just a poster from multiple organizations from last year.
Is that the date for 2022?
I should have looked that up. I don't know. It's probably close if it's not exactly. I don't know if they keep it on a specific calendar date or day of the week. I'm happy to answer any questions. I just get excited about wetlands. There's a lot of people that do a lot of research. There's a lot of scientists that do a lot of science related to wetlands. So I've kind of focused in on the constructed. Yeah.
Well, my differentiation with the other guy is that a lot of this runoff is agricultural. Farmers tile fields now.
Oh, they've been doing that for a long time. Yep.
When you tile a field, I one time was inspecting a crop, and I told the guy that farmed the land, I said, I can hear that water running in that tile. I said, is that possible? Yeah, you can hear it. So
yeah, that's amazing.
Runoff isn't just from what we as town folk think. It's from agriculture, and one thing you can see is in real wet season, the herbicide doesn't work as well. The chemicals don't work as well, because where are they going? They're being flushed down through the tile, the field tile.
Yeah.
And that goes into our water.
Yeah. So one of the other areas that I'm involved in is the Wabash Land Conservancy. Has anyone heard of that group? So I helped co-write an IDEM 319 implementation, well, there was one before I was here, but grant to try to provide cost share money to help farmers implement some practices that would reduce runoff and ultimately improve water quality. So putting in like grassed waterways through a field, get some cost share money to do that. Put some acreage, do some no-till, put yourself on a schedule. You can get some cost share money for the process of doing that, different things like that.
It's to plant right in the cover crop. Don't even do any tillage at all.
Yeah, no tillage is one of our
initiatives.
initiatives.
And then just plant in that cover crop.
Yeah, no-till definitely is beneficial.
Well, I call no-till. They
I see what you're
they
saying.
don't till, but they also plant a cover crop, and they
Yeah,
don't till.
okay.
When they plant their regular crop, they just plant it right
Interesting.
on top of that.
Yeah, yeah.
Does the state incentivize cover crop, or does the Department of Agriculture?
I don't know all the rules and regulations. Maybe someone here knows better than I do. I mean, I know through our implementation grant, we're providing cost share funds. So I think there are a variety of those types of grants, but I'm not sure like,
The Nature
Just the-
Conservancy and
I don't know the particulars, but I just read an article that said that farmers who want to go to no-till have to, it actually costs them some money, and does slightly reduce their harvest.
Yield,
So
yeah.
they do need some kind of support.
there's a lag time in that.
right. I think long-term, like, eventually it will benefit,
The problem
but
is if
year to
you're
year,
and you're paying a
Right,
farmer to do
absolutely.
this, okay, the benefit only accrues to the environment if the farmer keeps doing that year after year
Yeah.
after year.
so for our program,
And
it's
if
3
the farmer
years.
drops out, then all of the money that was spent
Yeah.
is lost.
Yeah.
So it's very.
So there's a commitment that's required. Our grant is for 3 years. I mean, I wish it were for more, but
I read that farmers
Yeah.
can take 30% out of the carbon out of the atmosphere. If they all could manage to do, the right sustainable growing, we would basically see immediate results, in a few planting cycles. It's really exciting, but it's hard to get there. It's really hard to get there.
yeah.
Can I ask a
Sure.
question? In your research, you talked about removing phosphate and nitrogen. But what about the pollutants that get into the water?
Yeah.
The poisons and the toxins and the...
Sure, you mean like if we were doing a wastewater? So stormwater, the main pollutants in stormwater are going to be the nutrients. But you're right, there can be any oil and grease that is on the road, any metals. So interestingly enough, one way to reduce pollution in stormwater is to clean your streets regularly, which unfortunately we don't do a great job of here in Terre Haute. Maybe West Terre Haute does a much better job. But just removing debris from your streets reduces or improves your water quality in your storm sewer system dramatically. So it's like, I was talking to one of my past colleagues, and he was saying when he was doing his first internship, he was a chemical engineer, and he was working for a power company. And so one of his jobs was to look at, is it more cost effective to clean the streets in the community more often, or put a more high-tech scrubber on their smokestack? And so I don't think he stayed long enough to find out, but he said he was working on that. So that was, years ago. So it is important to consider those others. And I think thinking about the CSO treatment of wastewater, that's where we're talking like the PFAS are going to be in there. We can detect, we have the analytical equipment to detect down to, micrograms, even smaller, nanograms. So we can detect things. We know that there's stuff in our water, unless you're going to do reverse osmosis, you're not going to remove everything from your water, but there's at least regulation in place for drinking water systems in the US, unless they're not following the rules, like in Flint, Michigan. Bottled water, there isn't the same type of regulation, so, it's muddy there in terms of but we weren't looking at that. We were looking at the things that the students were interested in, and they were interested in the nitrate removal and the phosphate removal. Could we look at other things? Absolutely, as long as we have the analytical equipment to be able to detect it. It's a great question. I think, we could look at anything. We could.
The system that your students built with the 3 levels, does each year's class redo that, or do you have
We have iterated.
everyone else?
Yeah, we have iterated. And, you know, Rose-Hulman is an undergraduate institution. We're not a research institution. So I don't have an army of people working with me on this project. I have one or maybe two a year working with me on this project. And so, you know, it's what the students are interested in. My goal is to help them develop skills. My goal is not to publish 5 papers with each student that I work with. So I really let the students pick what they're interested in, and we've iterated when it's not working. So when it starts leaking, then we blind it, and then we were still having problems, so we actually constructed them out of wood. We still lined them. So we have, you know, made improvements over the years as students have shown interest. And actually, I really look for students that are interested, but a lot of times the students that are really interested aren't necessarily the ones that are getting the high research opportunities somewhere else in the summer. And I love working with whoever's interested. And so I've had some really excited students, and they're usually excited because of something in particular. You know, one student was, you know, had a farming background, and so was just really interested in removing nitrogen. She knew it was an issue and that it was going in the tile.
Are there, you may not know the answer to this, but are there any particular plants that work better to remove?
Yeah, so the plants that we've, yeah, if you know about plants, please, I'm not a botanist by any stretch of the imagination. We've used plants that are wetland plants that, you know, are native to Indiana. We try to mimic that. It sounds like you have some background.
No, I mean, you definitely can do things with different plants.
Yeah, so that's something that if students were interested in that, I'd be happy to. There's a bit of a getting them established time lag. So there's just logistics there, but.
What about the role of oil extraction? Like specifically, I'm thinking Terre Haute. Does that impact the stormwater at all?
I don't know the answer to that question. I mean, there's going to be, in hydraulic fracturing, absolutely, there's an impact because you're pumping water that has chemical additives into the ground. But from normal oil extraction, yeah, there's waste associated with that. You know, something interesting in this area is that there's been a lot of mining, and so you know, you can see the acid mine drainage in some of the ditches when you're driving around. So I don't know the real answer to that question. Maybe someone else does. You all are very knowledgeable.
Are you finding more students staying on for a master's?
So we do offer masters. We have a course-based and a project-based master's option.
You still do crane too, right? Don't you?
We still do what?
Crane, weapons and ammunition depot at crane?
I have not, I'm not aware of that. I haven't been involved. Maybe you know more. Since I've been at Rose-Hulman, which this is my 7th year, I haven't had any master students in environmental engineering. We've had civil engineering master students in structural engineering, but I haven't had any in environmental. We offer an environmental minor, and I have chemical engineering students who are also interested in that, so civil and chemical. And I love that because we get different perspectives and we all learn from each other.
They know the plumbing.
Yeah, they're really good at the systems viewpoint and thinking about those different inputs and outputs. Any other questions? All right, well, thank you all. I appreciate your attention. Thank you.